Okay.
Yes.
So recording started. Yeah, welcome everyone. It has been a long break since the last time we did a meetup. 6 months, over 6 months actually. We're very sorry for this. But Arthur and I were really busy work-wise, and yeah, we couldn't keep up our monthly pace from the past, but we are back with a great talk and great speakers. And we also have a new co-organizer in our group, Ben Ferry. You might know him as Power BI guy from YouTube. Unfortunately, he couldn't join today. So yeah, you have to live with the four of us. But I think we've prepared some really cool stuff. And yeah, Arthur, do you want to take over introduction of the topic?
Yeah, it was a cool Christmas story I had with Michael, because he was firstly presenting his solution of Bin's and Lorenz curve at one of my talks in German actually, and then we decided to make it in English again, and then the magic happens around Christmas when Alberto was noticing about the code and improved it. Yeah, Michael. And with this, I hand over to you so you can tell the story along.
And we will see there was real magic happen, because when I just wrote it, it was okay with small data. So I wasn't able to do it with 100,000, 200,000 lines of data, but it immediately broke when we go to millions of rows. And Alberto was so nice and improved it. And he will explain what he improved, why he improved it. And now it works with millions of rows. I will show it. And yeah, therefore we will present first the dynamic binning. So how you can bin something by a measure. So this was my starting point. And then I thought, okay, if I can bin something by a measure, then I can say, okay, how is the attribution of 1% to my revenue, of my customers, of my products? So it goes a little bit in the ABC analysis. It goes in the Lorenz curve from the macroeconomics. And this is my part. Alberto.
So what did I do? Well, actually, I wasn't doing anything fancy. I was just browsing LinkedIn, as we always do when you don't have anything better to do. And I read your blog post. I have no idea what the Lorenz curve is, and I just didn't know you, but I mean, the chart looked nice. So I said, well, that's interesting. And you also put a picture of the code. Now, teaching DAX, it's quite simple to look at a piece of code, say, oh my gosh, that's bad. And what I really appreciate is that, I mean, you are sharing something. And that's, to me, the most important thing is people, whenever you do something cool or whenever you do something interesting, if you just share it on LinkedIn and write notes or do presentation, then of course, that's the easiest way to engage with other people and start collaborating. And it was nice because I still have no idea what I optimized. I just look at the DAX code, and I was most curious to understand what is this formula computing at all. So my part was making it faster, but actually the entire business logic is yours, and that's to me the best thing about collaboration. And as you said in the introduction, doing stuff in English. A lot of people still use their local language, maybe German, Spanish, Italian, or whatever. And you have no idea how close the world is if you don't use the language that everybody can understand. As soon as you use English, then everybody can contribute to your job. And that's the simplest and better way to me to start communicating. I mean, we probably would have never met if that didn't happen.
Yes. Okay.
I think someone was actively asking about it, right? That we should do it in English.
We started in German, and someone said, okay, can you do it in English? Because I tried to learn German while I'm watching you talking about the function. And we said, okay, we do it in English again, because there was some kind of demand. And after this, I decided, okay, now I can publish just the code and say, maybe I hope there's some improvement, because it was just oh, can I do this? And I could. And then I said, okay, now maybe someone has an idea how to improve it. And actually, the idea was from you. So just to explain you where I started, my starting point was I started with binning, and I started with distributions. And if you try to have a distribution over some kind of measure, it gets really, really tricky in Power BI because you can make a distribution by a group, but I want to say, okay, I want to know, in this case, how many days have a certain revenue. So this is over 3 years, and I can say, okay, how many days has a certain revenue? In this case, it's 2 million to 12 million. I can filter it and say, okay, a different filter and maybe a different country. So it's completely interactive. The filters does their work. And this was my starting point. So actually for this, there is also a LinkedIn post, so you can look this code. And I started with this. And after this, I was thinking, okay, if I can make a distribution, I can make maybe a distribution for, some are knowing it as ABC analysis. I can say, okay, my top percent of my customers, my top percent of my products are having rich impact on my revenue, rich impact on my profit. So I came up and said, okay, let's think about how can I present the top percent making rich revenue. So, and in macroeconomics, there's something similar. You say, okay, how is your income over a nation distributed? So 1% of a normal nation having like 50% of all the money in a nation. So, and for companies, it's quite the same. They want to know how is the impact on the biggest products, on their biggest customers, on their revenue. And this is the thinking behind this Lorenz curve. And actually, this one is a bad one. You see, it's take a while. It will work. It will work. So this is a bad one. This is the code I started with. And what you're seeing here is, okay, I have my top percent, and I can say, okay, the top percent has 6% on revenue. And I built in some slicers, so I can say, okay, 50%, it will work. I will show you the better one. And now I can see, okay, if I have 50% of my customers, I already contribute to 96% of my revenue. And you can do the same for profit, for a lot of KPIs. So, and behind this, there are multiple KPIs or multiple measures. One measure for showing the curve, one measure for showing each bar, and one measure for showing the line to get this cross. And basically, if I'm looking at this Lorenz curve, this you see old, and we see, okay, it's percentage. It's nearly always the same logic. And one major piece of this logic is that I'm working with a disconnected table for the parameter for my percentage. And then I'm grouping all my data based on the percentage. And these are the top two steps where I say, okay, I create this virtual table, and Alberto will talk about what I did wrong and how you can improve it to make the performance way better. So let me show what is the way better performance. So the improved code is when I'm going to good code, so it's immediately there. So there is no, it's instantaneous. So, and we are talking about 8 million rows. So it's quite fast, 8 million rows and nearly 20,000 customers. So quite fast. And to prove this even faster, I created a much bigger data source, and we go for the good code, and I can say, okay, let's just check if this is working. I say, okay, performance, let's refresh everything. And it's quite fast. And we're talking about 160 million rows nearly. So really, really good performance. If I do this with the old code, it will not work. It will break. So it's not enough memory to calculate it. And now I would like to, Alberto, what did you do making this so extremely faster?
Okay, I need to share my screen at this point. Let me jump there. You see the screen?
Yes.
Cool. So what did I do? The fun part is that I don't remember that, because I did that on purpose. It would be boring if I just tell you, well, do this and do that. So enough time passed that I don't remember what I did. I just remember that the changes were kind of small. Anyway, let's say that you have somebody like Michael or Mikhail, or how do you say that?
It's both, it's okay. Michael or Michael, it's both okay.
But Mikhail is your name. I mean, the German
In the
pronunciation.
German, yeah, it's Michael, yes.
Mikhail, cool. I mean, whenever that happens, somebody shows you a piece of code and say, well, it's slow or we have a problem. You always start in understanding what is happening under the cover, under the hood, which is performance analyzer, exactly as you did. Now, the thing about performance analyzer is that you need to spend a bit of time understanding the numbers that are produced, because now we have this beautiful new optimize button. You can launch the performance analyzer, start recording, and then we refresh. That's the only visual we have. Refresh the visual. It's going to take some time, and you see that we have several numbers. And now, in this case, I'm refreshing only one visual, so the numbers make some sense. But the first important detail is that the three numbers are equally important. DAX-Query is the time that it took to execute the query, 5.5 seconds, which is a lot of time. Visual display is always tiny. It's the time needed to show the visual. Other is a beautiful number because it means nothing at all. And a lot of times it's the largest of all the numbers. Other is the time that the visual had to wait in a queue before being executed. Now, if you have a single visual, like in this case, other is always small. But if you have something like, I don't know, multiple visuals like here, you see that in this case, other, for example, is 265 milliseconds out of 326. That means to generate this table, it had to wait a quarter of a second before running the query. And there's nothing you can do here. So you need to ignore this number. The only way to cut it is to reduce the number of visuals and only focus on the DAX query, because that's where you can work. So whenever you look at performance analyzer, let's clear and refresh it. Always spend some time expanding the content of the visual in order to focus on the only useful number that you have here. You can also sort in different way. You can sort by total time, action order, DAX query, evaluated parameters, or visual display. And the most useful way to sort it is the DAX query. But even though you sort it by the DAX query, the number that you see here is still the total, which doesn't make sense. You see that the time to execute Lorenz curve is 5 seconds. That should be at the bottom. Anyway, now that we have a baseline, you copy the query and then you forget about Power BI Desktop and we start looking at that in DAX Studio. Because there is where you start understanding the content of the query. And this is where we start. We format the query just in case. That's the first time I noticed. You see that the icons here are different than the icon you have in Power BI.
Yes. Because,
I didn't know that.
It's depending on what kind of emojis they can display. So.
Okay. Now, can you imagine how beautiful it will be to write these table names on my keyboard now?
Sorry.
Anyway, no, don't worry about that. So this is the DAX query. I quite never work with the DAX query as it is because most of it is basically useless. We have these summarized columns that places two filters and just compute the color. We don't care about that. That's part of the entire query, but it's not actually computing this part. So we can get rid of it. The final evaluate is evaluated via zero body limited, which is this query that is a sample of 3,500 rows. That's always there whenever you work with Power BI because it never gathers the entire query, but only a subset of it because the query might contain millions of rows. So sample or top N is always there. Therefore, we can get rid of it. And actually, the query we want to analyze is this summarize column. So let me cut it, place it here, and then we reformat. So we have a couple of filters, one for the color, one for the data. That's fine. And we have 4 measures plus the color. The first thing we need is a baseline. So how long does it take to execute this query? We need to enable the server timings. We could also enable the query plan, but just don't do it. 99% of the times you will need to optimize something. The query plan is useful because it provides so detailed information which are so detailed that are basically useless. And then we run it. It runs for some time. I don't know. That should be around 5 seconds. It's actually slower. Yeah, it takes 9 seconds to run. That's already interesting. I don't know the reason, but that's not so important. And these are all the storage engine queries which have been executed. Now we are executing 4 measures: color Lorenz, total value of revenue, total percentage, and percentage of revenue. Mostly there is one measure that is the culprit. Here we have 4, and we want to understand which is the slowest one.
I can help a little bit. They are they have all the same structure. So the
Yeah.
only the output value is a little bit different. So they have all the same structure.
That is entirely true, but I think it's useful to see that you don't know the help
okay.
of the author. You just start digging and say, okay, we have 4 measures. Something's gonna happen. I don't know. So having only 4, I would start removing one, then the other one. Otherwise, when you have a lot of them, you simply comment out half of it. Say, well, it started with 9 seconds. Let's see what happens now. If it still takes 9 seconds, I know the problem is among these two because these are fast.
Yeah.
If it takes 4.5 seconds, I know it's a split at the right half and half. It takes 6.2 seconds. Let's get rid of these two. Because you might think that now it should take the remaining part of the time, but that is not always true. A lot of time there is code that is shared among measures. And so the sum of individual measures is actually much larger than the total, which I don't know if this is the case. Yeah, it's 6 seconds. So 6 seconds to execute these 2 and 6 seconds to execute these other 2. That means probably each of the measure, as you said, is equally contributed to the old speed. Now let's get rid only of the color because that is likely to be the fastest one. Yes, this takes only 5 milliseconds, so we don't care about it. We just can kill it.
I would say you didn't optimize this one.
Yeah, I mean, you don't waste time here. It's only retrieving value from until that is German, until Prozent.
Oh, sorry.
What does until Prozent mean?
Share of percent.
Okay.
So some kind of share, yeah.
Okay, so now we have we basically have 3 measures, and we know that each of the measures is equally contributing to the time for the code. That means we need to look at them one by one. And then we start investigating further. So what is the code of the measure? Old percentage, if I go here and I search for old, we have the percentage of revenue per percent of customers. Hopefully it is this one. Yes. And the beautiful thing about DAX Studio is that you can just right click, define the measure. If you click on define measure, it adds between model measure begin and model measure end the code of the measure as it is in Power BI. That is good because it shows the code. Change the code here because this measure, so this query is going to use this definition of the measure, not the one in the model. But the measure includes, for example, here, sum of revenue, or sum of revenue again, or revenue total, or value percent. And maybe the problem is somewhere there, and we don't know. So instead of using the find measure, what you can do is right-click and use the find dependent measure. That defines not only, well, that doesn't work. The find dependent measure. Let's give it a third try. No way, there's a bug. Let me just write. So I write an email to Marco. Dependent measures not working. That's a preview of DAX Studio, so it's expected not to work. But anyway, if it worked using the find dependent measure, you would have seen the definition also of all the measures that are used in the current measure. That expands the entire tree of all the measures, and it's useful when you have measures that call measures, because you can change the code wherever you want, and that gives you more certainty about what you are doing. But we cannot do that, so we reformat the query, and this is where we start. Because I don't remember, let's take a look at revenue, for example. Because we are using
it's
revenue.
just a sum.
Okay, yeah. Revenue looks like just a sum. We have two different revenue. One here. Oh, that's the revenue in euro, and that's the revenue.
This is the virtual revenue, the second one. I should name it a little bit different. So yeah, it's
okay.
The euro revenue is the real revenue from the data model, and the revenue, the second one, is the revenue from the virtual table.
Okay. Whatever, I guess these are just sum. There's nothing complex here. This value percent might be.
It's just a selected value of a parameter. So.
Okay, so that is just grabbing the parameter. Revenue total is probably computing a total. So let's pretend that there is nothing wrong here. Everything is working as expected, and we are happy. Next, we start looking at the most common pattern. No, that's true. Let's go for long line, and we read it. One thing that I always do, I know people don't like it, and I don't even know if it is a good practice, but I just get rid of all the comments. Not because they are bad, but because when you focus on DAX, actually, I find them disturbing when I only worry about performance, because believe it or not, I'm not interested in what this measure computes. My goal is only to make it fast.
Yeah.
So
me, from a standpoint, if I'm writing DAX for customers or for myself, I always love some kind of comments to know, okay, what did I do in this measure if I'm looking in a measure three weeks or 3 months ago?
Yes, which makes total sense. I'm not saying that comments are wrong. Comments are absolutely fine. I only get rid of them whenever I'm optimizing, because when I optimize, I really, I don't want to know or to understand why you are doing something or what is the overall goal, especially for a measure that is kind of simple like this one. And then I read the variables one by one. Here we are using summarize, which is fine. You're summarizing sales by customer name. So this is grabbing all the customer names in the current filter context. But this is the evil, really probably the worst thing the newbies do all the time, because they don't know how bad this is. Summarize is a strange function. Summarize is able to group by. So what this summarize does, we can execute it somewhere else. Evaluate. It's just retrieving by customer name the amount of the revenue, which is fine. The thing is in the way it does. Summarize using a technique that is called clustering. That is, it will take the sales table, the entire sales table. It will split it into bins depending on the customer name. So if it has a table says contains 1,000, let's say 100 columns, it will find the values of that 100 columns for each different name, and then use that set of 100 columns as a filter. That stuff is explained somewhere. Let me search. I think I wrote about it in All the Secrets of Summarize. This article, I don't know if it's worth reading, meaning that if you want to go the quick way, you can just read the introduction. In the Definite Guide to DAX, so we deliberately omitted the syntax of summarize to generate new column. So we didn't write in the book that you can use summarize to generate new column as you are doing here. And the reason is because if you use that feature, you will need to read and understand all the remaining part of the article, which is just crazy. It explains you how clustering works, how things are happening, and why mostly the numbers that are reported are incorrect and slow. Summarize is good to do, it's the basic part. That is, you only use it to do the grouping. If you use summarize to group by customer name, that works. There are no problems. It does exactly its job in a simple way. But what you should never do is add columns using summarize because of clustering. So what if you need to make it fast? Well, if you want to make it fast, you always need to use a different pattern, that is add columns. You use summarize to do only the grouping by, and then you use add column to perform the creation of the column. The semantics is the same. The results might be different. I'm not sure that the results are entirely identical. But the thing is, the results returned by add columns are correct. The results returned by summarize are potentially wrong. So you do not want to spend time with results that might be wrong. But we also need to know that by changing that summarize to an add columns, we might change the result. And we are not sure about that. So when that happens, this is where you start debugging a bit further and you say, okay, let's go to this measure test. Now, let me take this original I hate that. Original measure as this one. So we call this test. And then in my query, I retrieve both the percentage of revenue and my test measure. Because I want to check that the two are still identical. I'm making a change in the code that potentially disrupt the code that I'm doing. So let's take my add columns, go here. And these customers we use add columns.
Huh.
So we start with the query. Let's get rid of test. I need the baseline again, because I don't remember how long it takes to execute. It was like
it's interesting. There's a difference between the summarize and the add columns. It's getting bigger when the value is getting smaller.
Now it's taking 10 seconds, which is crazy. It was faster before. And I didn't change anything. Oh no, I removed sample. That's the reason why it's slower. That makes sense. Now it's taking 6.6 seconds, which again is weird. I'm not used to this variation on a regular PC. That shouldn't be that large. From 6 seconds to 10 seconds, I would be happy because I optimized it, but I didn't. Okay, 6 seconds is the starting time. Then we use test. We run it, and it's still slow. 6 seconds. So that is not optimizing anything at all. Now, summarize sales by customer name, and you're grabbing the revenue in customers. Let's discover later. I would have expected this to provide some benefit, whereas it didn't.
But you mentioned before that this is add columns and the use of add columns and summarize can have different results. And I just checked it, and they're indeed different results. And
oh, beautiful.
So
I'm destroying everything. So let's check why they are not the same. If we retrieve both, I have an error somewhere. Argument 7 in summarized columns, I have a comma that is missing. Yes. Percentage of revenue per percent of customers. Yes, that's a measure. Let's run it. Now, they look the same. They do look the same.
Yeah, the percentage looks the same, but I checked it with old percentage. Nah, 1 second. Maybe I have the wrong thing.
Let's one minus the other. So if I see 0 everywhere, I'm happy.
Oh, sorry. Maybe I used the wrong fields.
Yeah, to me that looks correct. The numbers are equal.
Percentage of value values. Oh, but we can discuss this later. It's interesting.
Because your values are different.
If I do it, yes, I get some different values. Should I shortly show what I mean?
Yeah, why not?
So 1 second. I have to share. We will reshare your screen. So I just used a deviation, and now I see, okay, I've on the one side, I use the percentage revenue per customer, the new one and the old one, and here I see for the small bins slightly different different values. So it's really, really small, but there are differences. So really small, but they are there.
Okay, but this is not what I'm doing right now. You're using already the final version.
I'm using already the final version where you changed the two first calculation, but maybe the change.
I think it's easier if we go there later. Let's finish it, and then we do that, and we check the problem.
Oh.
Because right now my measure is still slow, so we need to do something else, which I totally don't remember. Let me go back to the screen. That is it.
Just in case I have the solution here. So.
Yeah, I know, but where's the fun part?
That's true.
Then we have, anyway, this now should work. It's summarizing customer name by revenue. Oh, what is revenue? You have a column revenue, which you use
in the rank X function.
In the rank X, you rank X customers based on revenue, and that's the measure. Okay. Ah, that's interesting. I'm thinking about using the new window functions, but let's do that one step at a time. Okay. We have this customer. Oh, this is computing the number of customers, of customer names. Then you're doing all on the customer name, and you're checking that there are revenues. Okay.
Because I have some customers in my dimension which have no revenues, so these are not for calculating.
Yes, but oh, filter sales. That's awful. I get it. Now, this filter is filtering. Look at that. You are counting the customer names. Okay. You're removing any filter on the customer name. So this is computing the number of all the customers with sales. But the filter you are placing here is based on an iteration of the sales table where you are computing the sum of revenue, and that should be different than blank.
Yes.
Now, when you write filter sales, what you are doing is you are filtering actually the sales table. You're not filtering the customer table. You're filtering sales. That means that this iterator will scan the entire sales table containing potentially millions or billions of rows to find the combination of rows in sales where there are no revenues, and then use that to filter the customers using the expanded table. Now, the expanded table of sales contains all the columns of sales plus all the columns of all the tables that can be reached through a many-to-one relationship. That is going to take forever because it strongly depends on the size of sales, and you're actually not interested at all in the in placing a filter over sales. So what you could do here is just filter customer, for example, not customers, but customers with the emoji. Okay. And that should make it already way faster because we got rid of the filter over sales. We just filter customers. Then we can probably write it a bit better, but that I don't know. Let me see. I'm retrieving only my test. That looks better. If you look at the server timings, now it goes down to 77 milliseconds, which is 1,000 times faster than before. Just because we didn't have this filter over the sales. The filter now depends on the number of customers, and we have a small number of customers, I guess a few thousand here. You can do that this way, but again, that requires you to compute the sum of revenue. Something that you can do, let me check revenue. Where's revenue?
It's
here it is.
Started, yes, yeah.
Okay, let's define this. It's just the sum of sales revenue.
Yeah.
You can do that this way. That makes sense. Depending on the distribution of data you have, you might be in a situation where, no, actually, yes, you might be in a situation where it's enough for a customer to be in the sales table to consider it as good. So either you have customers that have sales equal to 0 in the sales table and you don't want to count them. And if that is the case, this is the code to use and it makes sense. But mostly when you are optimizing, you might only say, well, you know what, as long as the customer is in sales, I'm happy. I want to consider it as a good customer. So all this stuff can be written in a different way by doing count rows. No, actually, it's just a distinct count of the sales customer key, because that retrieves the customer key. And here where the problem appears, and then you use all customer name.
You can use all customers key. It's, I would say,
you can use all customer.
Okay.
Why not? I don't know if that is what you want. So if you are interested in all the customers.
Yeah, you can use all customer key because it's better than you use customer name, because there can be doubled name or something like that.
Yeah, no, actually that's a bit more intricate, because if you use a distinct count of sales customer key, then the distinct count will only operate on the sales table, so it's going to be faster. But you can count the customer keys. You cannot do a distinct count of customer name.
No.
Okay, because if you want to do a distinct count of a customer name, you need to filter to reach the customer name, and the filter doesn't go there. You can distinct count customer key, but that is not producing the same result. So if I compute it this way, that's gonna be, yeah, the time is the same, there are no differences, but now I expect the numbers to be different because this is grouping by customer key, whereas before we were computing customer names. And in case you have two customers with the same name, you are in trouble. Indeed, if we compute them at the same time, now I expect the two numbers to be different.
Yeah, they're slightly different. I looked this up.
Yeah, but we do have percentage. There's an error somewhere. Yes, always commas missing. No results, but they look the same, but they shouldn't.
Yeah, if you see the next digits, I guess there's a small difference. So
yeah, let's get rid of automatic formatting, because here we see always 0, but if we get rid of auto format, where are you? Results, let's get rid of that. Let's run it again. Yes, there's a difference which is tiny, but it's there.
yeah.
So you need to make a decision. Either you use this pattern, but that means we need to use customer key everywhere. Or because we cannot do a distinct count, we can do a count rows of summarize sales by customer name. This summarize is going to scan sales, group it by customer name. So it's only retrieving the customer names as we are doing above. It's not as fast as doing a distinct count of the customer key, but it is still quite fast. We can get rid of that. And now I would expect the numbers to be the same. We just need to check the performance are still good. Yes, now the numbers are all identical. That is good. And we just take a look at performance. That's good. It still runs fast. So basically what we have seen that this was basically useless. This is the change that actually changed everything.
Maybe I repeat what you write in the email. The first thing was bad, and the filter was bad, bad, bad. So
okay,
with exclamation marks.
That was even worse. Yes, filtering a table is quite always bad. I mean, that should be something like a Pavlov bell. When you write filter sales, at this point, something should start ringing in your head saying, oh, this is bad. I cannot filter a table, never. Or you can, but then you will spend a lot of money in consulting because somebody needs to come and fix your code. That is a waste of money. Then you use add column to the customer to rank the customers by revenue, which is the column you place here, which is fine. And then the customer position. What is that computing? Rank divided by customer, all 0 times 100. Oh, it's the position as a percentage.
Yes.
Okay. And then you summarize customer with the position to compute the running total. And then you compute other stuff. That is fine. Now, I'm wondering if there is a way to compute the same stuff using the new window function, and probably yes. But
I was
that's gonna take forever. Anyway,
but
these are the two. Yes,
with this adaptation, the function is really, really fast. So I use this with 100. 1 second. I have to say it. nearly 160 million rows in the fact table, and it's computed under half a second. So
yes, but still this part, the problem we have is only here. I need to change the battery of the microphone. Just give me a second. Okay, here I am again. Now, the problem of this code is here. This code does not depend. Your code, the version you wrote, was using a filter over sales here. So that code depends on the size of the fact table. The larger the fact table, the slower the measure.
yes,
This code does no longer depend on the size of the fact table because we are using okay. I was just saying that looking that we're using the same code here and here, so that's a perfect place for a variable. But we're scanning sales here, here, and that's it. We never use it sales.
yeah.
So the speed of this measure does not depend on the size of sales. It depends on the size of customers, because you are iterating over customer. You're scanning customer here, here again. Here you are iterating over customer. So depending on the size of this customer, it might take longer. Depending on the size, but this is still linear. So twice the number of customers, twice the amount of time. The real problem appears here. Because you're using with customer, you're using customer again, you're using again summarize to compute this percentage, which is absolutely bad. But here you are computing, you're iterating over a table that computes all the rows that are less than the previous value. So you're basically scanning twice the same table, and you are, for every row of the customer table, you are aggregating all the values that happen to be above or below it. That depends on the way you implemented it. That goes quadratic. It's no longer linear. So with the growth of the number of customers, this measure depends on the square, on the number of customers squared, actually squared and then divided by 2, meaning that if you double the customers, it will be 4 times lower. And if you make it 10 times the number of customers, it will be 100 times lower.
Okay. So
that is where window function might be useful, because window function go back to linear. They are able to do calculation like this, but they do that in a linear way. So you get rid of the quadratic part. But let's stop here and let's see what happens if we change, because actually we have only these 2 variables. That's the only change we did. So we can now take this code, go where we have the Lorenz bar, and the thing that I didn't highlight is that these 2 variables, customers and customers all, appear here, and then they appear also here, and they appear also here. That's the very same piece of code. So optimizing one is going to optimize everything. So we can just replace this part. And then this part. It's also nearly the same length. And this part. Well, actually, we should have restored the comments, which I didn't do. But probably this is already enough to make it run faster, like changing the filter. Yeah. Now it works nicely. Making it even faster. Oh no, let's say you mean that we have a problem somewhere. You know where the numbers are different, so we can check it.
I'm not have checked this with this new version of yours. It was just it can be because I counted a little bit different, so that there's a minimalistic different between the total number. So the change is between 0.1%. So
yeah, but that's still a change. So let's. Oh, you have the new version. This is what I wrote at the beginning, right?
Yes. So the new version is what you provided.
Does these add columns? Oh, this is doing that by customer key.
Yeah, because you mentioned rightly that the name can be doubled, and it's better to say, okay, it's better to make it by customer key.
Yes. But of course, at that point, the numbers will be different. So this version, the one we have here.
Oh, yeah.
That should be the same as yours. Yeah. Because that is grouping by customer name, which it's important to know that it might well be wrong because two customers with the same name, they will be aggregated under the same customer. So if there's some Alberto Ferrari that buys a lot of stuff, I will be aggregated with that guy, and we would appear as the same customer. So grouping by name is quite never a smart choice, unless you really want to group by name.
It was just to make it in a, I was just writing it down and then, oh, I group it by name, but obviously it's not right.
But if you group it by key, as I'm doing here, then things are different, because if you group by key, the same customer would be split into two customers, and maybe both customers, they will fall in a different bin just because they no longer represent the sum of the two. So it makes perfect sense that this produces a different number.
Yeah, it's slightly changed, but yeah, it's just I guess 3 or 4 customers per bin. But yeah,
we can check that. If we just evaluate all columns, all customer name, customers, we just do a count calculate. I calculate the count row of customers. And filter this stuff. Where, let's not call it cust. Let's call it at the customers greater than 1. Yep. This is counting is grouping by customer name, counting the number of customers with the same name and retrieving only the rows where there is more than one customer. And you know that all these guys, they are duplicated. So the difference depends on the amount of sales of these guys that would be split into 2. If you use the grouping by customer key, and they will be aggregated together if you group them by customer name. So that actually depends on the specs, how you discuss with the user or how the code has been generated. But it makes total sense that this version, okay, no, I don't know what I'm doing. Okay, this version of the code that uses summarize and summarize by customer name, they should produce exactly the same numbers as yours, just faster. Whereas the one grouping by customer key, that potentially is wrong. It produces a different result, and the difference depends on the number of customers with the same name that would be duplicated in both cases. Using windowing function, I don't know how we can do that, because that requires.
I have another question. I have another question for you.
Yeah, go ahead.
Can you open the Power BI file?
Sure.
And can you click on ABC?
ABC, yes.
So basically, I thought, okay, I know each percentage, and I can say, okay, I know. I can say how many % of the customer are responsible for 80% or for 70% of my revenue. This is all the red ones. up to 90% are all the red plus the gray ones, and all others are the restly 10%. The problem what I have is I can't use this calculation to make a classification on my customers. So I just can do it in this graphic, but I'm not able to say, okay, I want to have the percentage or the classification next to the name of the customers. So this was for me, I was trying it and I was, okay.
So for every customer, you want to know the percentage. So this number divided.
So if they are in the top 1%, top 2%, and obviously if I know the percentage, I can say they're in the class A, B, or C. So
what is this using? Percentage of revenue per percent of customer. That's the same measure we use, right?
Yes, it's exactly the same measure. The only difference is if you go to ABC segmentation on the right thing, on the field side.
Oh. Okay.
And if you open it, you see color ABC. So it's the same measure. The only thing is, in the end, you see the result, and if it's bigger than this,
okay, red, otherwise, whatever.
And what I can't do, or what I was not able to do, is to use a name. So say I want to use this red gray on the customer name. So I was not able to ignore on one side the filter context of the name, and on the other side to say, okay, I now want to exactly know what kind of grouping they are in dynamically. I know I can do it with some kind of extra table, but I wasn't able to do it dynamically, that I can say I can filter and I can look for products. So
what you want to have is the name here.
So exactly, I won't have the
A,
name.
B, or C.
So 1% or ABC. So it's basically the same calculation can apply for both.
If you place it here, it's not going to work.
It's exactly, it's always red because it's filtered by the name, and the name is always translated, and then it's always red because it's in the top percent.
I get it. So let me see this ABC class.
So this was something different. It's just on the table. So
yes, but what is this computing? Share ABC. Well, that is wrong because this is summarizing only.
It's basically the same measure as before.
But that's the same code that I sent you? That's
yeah.
No, it's missing this part.
Okay.
You see that here I'm grouping by customer name, but I'm doing all on the customer.
It's basically the same code, but it works. So this is.
No, it is not.
Okay.
I mean, if you use all customer here. It's not customer, okay. And we use it now. Shows red everywhere. Still, yes. Why? This is called ABC.
It was just a question. So I was just trying it. So no need to.
No. I mean, this part is wrong because what you want to do, these customers is grouping sales by customer key. So this is actually grabbing only one customer.
Yes.
If the customer is in the filter count, like Janet Manots.
Yeah. Oh, you mean in this context? Okay. So
yeah, in this context,
the problem is
this shows only one customer.
The problem is, but I need all the customers because I need to know in which position they are.
Exactly, but you're not doing that here.
No, I'm doing it later. So, but I need the first calculation to say on which percentage they are, because I only can say
where are you doing that?
Later.
Where?
So I get rid of them, but the problem is I don't know where I can get the percentage for each single customer.
No. The thing, what I'm asking is, you want to find the position of Janet Manots.
Exactly.
In all the customers, right?
exactly. I want to find her revenue position in all the customers.
Okay. Now in this code, this is summarizing sales by customer key.
Yeah. Ah.
When you are here in this cell, you're showing only the sales of Janet Manots.
Yes, it's right.
So this is going to return a table with only one row.
Yeah.
That is
Yeah,
Janet
exactly,
Manots.
exactly. This is my problem. Yeah, exactly.
And you are not doing anything later to find the ranking. All this ranking will always produce one, the position of
Yeah, completely right. So therefore, I didn't use this for this one. I was just using it on the table. And I said I didn't get it to do it in the right filtering. So maybe I have to write a completely different.
But if no, why not? We can do a calculate table of this stuff. We get rid of the filter over the customer. No, of the customer with the icon. See how much I love it.
So
Okay. That still shows red everywhere, so there's something more to check. Now, this is computing the sales of then all the revenue of all the customers. This is counting all the customers. This is ranking the customers by revenue. This is computing the percentage, the position in percentage, and that makes sense. Then this is summarizing customer with position. That is something that I really don't like. This revenue total. What is this revenue total?
oh,
Customer position by
peer. It's more or less the total revenue of all the customers in a certain bin. So I calculating the total revenue of all the customers in my 1% bin, in my 2% bin, and so on. So to say,
because PRC contains a one. Oh, I get it. I get it. So summarize, will it work? It should, but that is probably better done through a group by customer, and that is sum x over the current group of not the revenue, but you already have revenue there.
Yeah.
Then you filter the percentage, which is less than the value percentage from this, and then you iterate.
This is just to get the share.
Yes. Revenue total, which is already there. Okay. No, that's wrong. Oh no, that is group by already. Okay.
Okay.
Okay. Yes, but I mean, yes and no. No, we need to change this a bit more, because these customers is grabbing all the customers. This is grabbing only all the customers, and then again that works with or without these all customers. But then you are never using the current customer only. So you want to know where the customer happens to be.
Yes, and this is my problem, that I was not able to filter the table because I have this virtual table with a percentage, and then I need to filter this virtual table by the filter context, but not using the filter context of calculating the virtual table. So this was my problem, what I wasn't able to achieve. So it was possible for the chart, but I was not able to say I can get the value for each group, so for each customer on the table, because there is a filter context, and the filter context filters this, and this just not worked. So, but
I'm thinking, but you basically want to know where that guy is. So you want to know the position of that guy. It's
Yes.
ranking.
Yes.
The position of the guy. I mean, you don't need, oh no, you need this stuff for the revenues. No, you don't, because you're only interested in the position.
Exactly. I'm only interested in the position. So this was just because I want to use it in the graphic, but if I want to have it for one customer or one product, I just need the position. I just need the position.
You don't need all this stuff.
Yeah.
Is it right?
Yeah, sure. So you need only the position. Because of the position, you can say, okay.
So if you get rid of that, this is the customer position. And then in a new variable, current customers, you grab the values of customer key. And then average position, you might have multiple customers, which is not your case, but you might have it. You filter your customer position where customer, no, it's always this. In current customers, and you average. That is really awful, but you average the position, which is PRC. And that it gives you the average position, which is already multiplied by 100. So you check the average position.
So
it should be.
Yeah.
Yeah, you're using 70, right? Not 7. Because you divided by and you multiply by 100.
Yeah, there are two different versions. One I had with, But you also can use the percentage, because if you see that there are different percentages to make the grouping, then it's more or less easy.
Yeah, but now I'm just making some tests. I'm not sure that this stuff works. Huh?
Yeah, for sure.
Indeed, it still returned red everywhere. Which is clearly wrong. I don't know. We need to spend some time trying to understand how to fix this code.
Maybe I will try to solve this, post my code, and you make it faster.
No, but the idea is that this version works. So here for the color ABC, only for this measure, you want to go outside of the current filter context. You create the customer table for everything. Then you count all the customers. That is fine. Then you rank them, which makes sense. Then you find the position. Then you grab the current customer and you filter out of the customer position the customers that are currently being selected. This is the only part where you obtain a number. Let me see what happens if I return average position. That's always 1. No, it's different. 24, 45.
Can you sort it by average position?
Yeah, we do have 100
so
here.
It looks quite okay. So this could work.
Yeah, I think the only problem is that we have too many of them, so we don't see it.
So yeah, but it looks as this would work.
Yeah, but we can do.
So
yeah, I mean, that's the fun part of debugging. New measure. Let's call it test. And here we return the result. I want to see both the number and the string. So we place this here. Yeah, that shows right. I mean, before we were seeing only red because probably there are a lot of customers here, and it takes forever to browse them.
Maybe just click on ABC and we will see red in the different way. So
yeah, now you see that between
yeah.
When it changes from 90.50 to 90, that turns to gray.
Yes. So it works.
And then at the bottom, it will be a different one. So basically, the problem here was that if you don't have a filter of a customer, then your code works. But actually, it is all ensures you that you're computing the customer table and the customer all for all the customers. But then you need to use the current customer, if you expect a filter on the customer, somewhere to extract from there what you're interested into.
Very cool. This was amazing.
Okay.
There is also a great example of measure totals with a 50.5 color ABC, and the red is the total.
Yeah, I mean, this is the average of the position, so I have no idea how that is computed. But these times talking about measure totals is always dangerous. Everybody starts a religious war about whether totals are right or wrong. And that's not something that I even want to start. Okay. I was checking. No, I just want you to save this. Okay, because I want to send it back to you so you can check the code and play with that.
Thank you very much.
But it didn't save because of that whatever issue. I didn't monitor the chat at all, so I don't know if anybody made any question.
There were some, but I think most of them were answered along the way. Or Arthur, do you have any question that we missed?
Maybe this was.
There was a lot of feedback regarding
there was like
Studio.
lots of good feedback. Then assigned some kind of easy question. So if you work with commenting and measures for debugging, do you always put the commas in front of one new line? From UV. I also do it like this, but I think the DAX formatter does not, right?
Yeah, it doesn't formatter. DAX formatter doesn't like it a lot, and I don't know. That again starts a religious war because deciding whether the comma should be at the beginning or at the end is always a problem. I like it at the end. I totally understand that it's incredibly boring to remove commas here and there all the time. But the best idea that I have ever seen was in a language that I was looking at a few days ago, where basically the engine is designed to ignore commas, the last comma of a query. So you can write this at the query, and the engine says, oh, this is the last comma in a query. I just get rid of it. I ignore it. That means we could use whatever standard, and that would work everywhere. But DAX will probably never do that. So I use the comma at the end because I'm too geek to be able to read.
It looks better, but I also then some kind change to make it in front because it's just practical.
Yeah, but also, so you see, there's this beautiful debug commas. You click on that and the commas go the other way.
Cool.
You never use that?
No.
You see here, we have these debug commas. If you click on it once, then the commas are nice to read. But if you click it then in debug commas, then the commas go at the beginning and you can comment lines in an easier way. This
is one good example of such a community quick win. So there's an easy feature always overlooked. And as I see in the smileys, I'm not the only one here.
No, I
have missed it.
I saw the button, but
yeah, that's that.
I think.
To be honest, it came to my mind just because I'm talking to you, because I never used it in my life. I knew it was there, and answering, I said, oh, but we do have a feature for that, but I didn't remember it.
Nice. Also, one more great quick win. Yeah. Then there was like a comment, but it's more a comment from Andrea about the filtering. So I think it's not a question anymore. If it is, Andrea, just protest in the chat. We also can unmute you.
Well, if everyone else has questions, now is the chance. Post it.
Michael, the other Michael also proposed to use rank and count, but it's already, this you already do it, so that's fine. And I think the rest is just appreciation and lots of thanks. Great. And I think the best stars are doing live performance.
I can unmute you, Andrea, if you.
It should be possible now, Andrea.
Yes, now it works. Hello. So it's such a great session with a lot of insights. Thanks a lot. I had the comment about the filtering of the sales table, because the original version filtered by customers with sales in the filtered date range. And the solution now doesn't filter. So there's just a difference in the versions.
You are right, are you? I'm not sure. No, yes and no, meaning that this customer all right now is computing the customer names, ignoring the filter on the customer, but only for the customer names that are visible through sales, and sales is this filter by date or whatever. So any filter on the date will still work here. There was another comment that says, yes, but if a customer has sales which are then deleted or corrected and the sum is 0, actually you don't want to count him.
Yes.
And that is correct. This version does not do that. If you want to obtain that version, you basically do, instead of doing summarize sales by customer name, you go back to the previous version. So you filter all customer name. With no calculate, you just do a count rows of filter all customer name. That is closing filter. And here you write the sum of revenue greater than 0. That version that will remove the filter only from the customer name, so scanning all the customers, checking that the revenue is greater than 0, returns a table with the names, and then counts how many guys are there. That works. The problem with the original formula was not the filter. Filter was fine. It was a filter over sales.
Yes.
Sales is the fact table, and using that as an argument of calculate. That was the real problem. Because say if sales contains 1 billion rows, that means you actually need to materialize a filter over 1 billion rows and then use it as a filter. And DAX is gonna, hate you first and die in the middle because you don't have enough RAM to generate that filter. So these are all variations, but I don't think this is going to be different in terms of performance, or it is. No, there's an error somewhere. Invalid token line 1 offset 5. Line 1. Okay, I will probably have the selection. You see, it's still very fast. 60, 70 milliseconds, there are no differences. The difference, when it's a tens of milliseconds, you don't even think about that. And that implements a different semantics. So all of them are nice. The word thing was just filtering sales. not filtering, but using filter reverse sales as an argument of calculate. That was the real issue.